All right, let's talk about something you've probably never thought about, but it's a quiet revolution happening right inside your dentist's office. We're talking about a massive shift away from all that plaster and those physical molds into a world of pure digital precision, cloud storage, and artificial intelligence. This is the story of Gnathology 1.0 moving to 2.0. So let's dive right in. But first, let me ask you something. Have you ever really wondered what's going on behind the scenes at your dentist? Past those super clean, sterile rooms? Well, chances are there are closets, maybe even entire rooms, just filled to the brim with shelves, and on those shelves are thousands and thousands of old plaster models of teeth. And that right there is where our story really kicks off. Okay, so Section 1, Dentistry's Plaster Problem. Look, for decades, dentistry has been running on this very physical, very material-heavy process. And as it turns out, this old-school method has some pretty significant and honestly kind of messy drawbacks. And when you put the old way next to the new way, the difference is, it's stark. It's night and day, really. On one hand, you've got what we're calling Gnathology 1.0. That's all physical plaster models, super expensive materials, and just so much waste and clutter that you literally have to find a closet for. But on the other side, that's the future. We're talking clean digital files, super efficient software, and everything stored neatly in the cloud. It is the classic analog versus digital story playing out right in your dentist chair. So let's really dig into the hidden costs here, because they add up. First off, you've got the expensive precision materials needed just to make the impression. Then every single one of those models creates a ton of plaster waste. And of course, all these models have to go somewhere, eating up precious, expensive physical space. But maybe the biggest problem of all? The data is totally static. It's just a snapshot in time. It's a physical object that's incredibly hard to track or compare as your dental health changes over the years. So what's the solution to this big plaster problem? Well, that brings us to our next section, the shift to Gnathology 2.0. We're talking about a whole new way of thinking, one that's built on data and, you guessed it, powerful algorithms. So what exactly is Gnathology 2.0? Well, to put it simply, it's all about swapping physical stuff for digital information. It's using computers to simulate everything a plaster model used to do, and honestly, a whole lot more. By using digital scans, patient data, and AI, it can design and help create dental work with incredible precision. Now, this whole new approach really boils down to two main things, two big technological pillars. The first is something called the virtual articulator. Just think of it like a perfect digital copy of your jaw, one that can simulate every little chew, grind, and movement, all inside a computer. And the second piece, and this is really the star of the show, is the AI-powered software. This is an intelligent system that can literally understand the shape of a tooth and then generate or repair it all on its own. All right, next up, training AI to rebuild teeth. Okay, but how in the world does that AI actually work? How do you teach a machine to understand something as complex and unique as the geometry of a human tooth? Well, it actually starts with a pretty clever and surprisingly simple experiment. So, how do you teach an AI to be a dentist? It's a great question. And the answer is, it's nothing like how we learn. There are no textbooks, no lectures. For an AI, it's all about data, recognizing patterns, and just tons and tons of practice on one very specific job. Okay, so here's step one. The whole process starts with a really clever task. The researchers basically took a 2D picture of a perfectly healthy tooth. And then they deliberately damaged the image, digitally of course. They created a puzzle for the AI, and the puzzle was simple. Fix this. Figure out how to fill in the missing piece. Then comes step 2. The AI gets to work. Now, it's already been trained on thousands and thousands of images of whole teeth, so it knows what a healthy tooth is supposed to look like. It analyzes that broken picture and generates its best prediction for what the missing chunks should be, all based on the patterns it's learned. And step 3. This is where the magic of machine learning really comes in. The AI's repair is then compared to the original perfect image, what we call the ground truth. By seeing the difference between its guess and the right answer, it learns from its mistakes. It does this over and over and over again, getting a tiny bit better each time, until its repairs are just unbelievably accurate. And that's the whole idea right there. The goal is to perform this same magic, but on 3D models. That simple 2D experiment is just the proof of concept. The real goal is to take this exact same learning process and apply it to the super complex three-dimensional data you get from one of those modern mouth scanners. It's about making the jump from fixing a flat picture to building a perfect 3D crown. And here are those 4 steps laid out. It's the AI's curriculum. First, it masters a single tooth. Then, it learns that tooth's place in the neighborhood, the dental arch. After that, it figures out the relationship between the upper and lower jaws. And finally, the masterclass. It adds the dimension of movement. So let's break each one down. Now think about how a human does this. For a person to do this kind of work, they have to learn a mountain of really complex rules about how teeth are supposed to line up. We're talking about things like Bonwell's triangle, the Bulk-Will angle, the curve of Spee. I mean, these are all complicated geometric principles that humans developed over 100 years to guide them. But here's the absolute game changer. The AI? It doesn't need to be taught a single one of those rules. Nobody programs it with the curve of Spee. By just analyzing countless examples of healthy teeth, it figures out all the underlying patterns and principles completely on its own. In essence, it writes its own rulebook, and that rulebook is way more complex and nuanced than anything a human could ever write down. So where is all this headed? What does this mean for the future? That brings us to our final section, the future of automated dentistry. Because when this tech is fully rolled out, it's not just an improvement. It's going to fundamentally change how things get done in every single dental office. The future workflow looks something like this, and it is incredibly streamlined. Step 1, a quick scan of the patient's mouth. No more goopy impressions. Step 2, the AI takes that scan and almost instantly generates a perfect custom-fit design for whatever's needed, a crown, an inlay, you name it. And then step 3, and this is absolutely crucial, a human, the dentist or the technician, inspects the AI's design, makes any final adjustments, and gives the final okay. So you can see how the role of the human professional completely changes. They're no longer a manual modeler, a hands-on artisan painstakingly carving and shaping things. Instead, they become an expert inspector. All of their deep knowledge and experience is now used to oversee and approve the work of this incredibly powerful AI tool, making sure the final result is absolutely perfect for the patient. Which really leaves us with one final fascinating question to think about. Will your next crown be designed by a human or an algorithm? And as this technology keeps getting better and better, the answer is probably going to be both. It points to a future where human expertise and artificial intelligence work together, hand in hand, to create a standard of care that's faster, more precise, and more efficient for absolutely everyone.
Let's talk about digital dentistry. We all know teeth are these incredibly complex organic shapes. So how in the world do you capture that natural artistry inside a computer? Well, we're going to explore how some new tech is moving way beyond the old methods, giving dental artists tools that feel less like software and a lot more like a sculptor's clay.
So let's just pause on that question for a second. We are not talking about a simple box or a sphere here. A tooth has all these super subtle curves, these sharp edges, and completely unique surfaces. Getting that right, that's not just art, it's a science. And the digital tools have to be totally up to the task. Okay, so to really get where we're going, we first have to understand where we've been. Let's kick things off by looking at the standard approach that's used in most dental CAD software today, and, why it's starting to show its age. Right, so the foundation of most digital dentistry is a file format called STL. You can think of it as a universal language for 3D models. But here's the thing, its entire vocabulary is based on just one simple shape, the triangle. It creates this kind of digital skin, or a mesh, made of countless tiny triangles all connected together to form an object. And this is where you hit the big trade-off. For flat surfaces, triangles are perfect. They're simple and super efficient. But a tooth isn't flat, right? To create a smooth, organic curve, you have to throw a massive number of tiny little triangles at it. The more detail you want, the more triangles you need. And that just means more data, slower performance, and a much heavier load on your computer. It's really kind of a brute force approach.
And here's where that becomes a huge problem in dentistry. The most critical parts of any restoration are the edges, the finish lines, the margins of an inlay. They have to be incredibly precise. With a mesh made of triangles, defining these sharp features accurately needs a crazy high density of points, which makes them really hard to create and even harder to edit later. Mastering these edges has been a major hurdle for a long time.
So, if triangles are the problem, what's the solution? Well, it involves thinking less like a computer and more like an artist. It's all about finding a way to model with that same intuitive feel you get from sculpting a piece of clay.
And it turns out the issue isn't just the fact that we're using triangles, but the chaotic structure they often create. To really see what I mean, let's compare two totally different ways to build the surface of a digital tooth.
So, on one hand, you have the typical machine-made mesh. This is what you often get when software just automatically converts your scan data into a surface. It's this complex, regular web of polygons. I mean, look at it. There's no rhyme or reason to how the lines flow. Trying to make a precise, artistic change to this is like trying to smooth out one little wrinkle in a crumpled-up piece of paper. It's almost impossible. But now, look at this. This is what we're calling the artist's grid. Instead of that chaotic web, we have this clean, organized grid of four-sided shapes, or quads. See how the lines flow so logically over the shape of the tooth? This structure isn't random. It's designed by a human for a human. It's literally built for editing.
And this clean structure totally changes the game. You can just select an intersection point on the grid and then push it, pull it, or move it. And because the grid is so well organized, the whole surface adapts smoothly and predictably, just like you're shaping clay. You're not fighting with the model anymore. You're actually sculpting it.
Now, this whole digital clay idea isn't just a cool concept. It's a reality in powerful platforms like SolidWorks. There are actually two main ways to get this kind of intuitive modeling, so let's take a quick look at both of them.
The first path is a tool called X-Shape. You can think of this as the next generation approach. It's designed from the ground up to add this intuitive, free-form workflow to the powerful SolidWorks environment.
So X-Shape is a modern browser-based tool that lives on the 3D Experience platform, which is great because it means you can access it from anywhere. It's built specifically for this kind of free-form, organic surface creation. What's really cool is its flexibility. You can design everything in the cloud and then seamlessly bring that sculpted tooth right into your traditional SolidWorks design on your desktop. It really delivers that hands-on, clay-like experience we've been talking about. Now, the second path gives you that same level of control, but through a really powerful add-on software from Integrity Wear Inc. called Power Surfacing for SolidWorks. This takes a bit of a different approach by bringing that digital clay functionality right inside the desktop application you already know.
So this tool from Integrity Wear brings that digital clay workflow directly into the familiar SolidWorks environment. It uses this really clever process where your scan data gets converted into something called a subdivision surface, which is just the technical term for that clean, editable artist's grid. And, crucially, it saves your work in a way that preserves that beautiful grid, so you can always go back and fine-tune your design with that same intuitive control. Okay, so creating a beautifully sculpted crown is one thing, but the real power comes from what you can do with that model once it's made. Using a whole platform opens up a completely new world of possibilities that go way beyond the shape of just a single tooth. This is where things get really exciting. Within the same system, you can simulate actual jaw movement to test how your design functions in the real world. You can analyze how food will flow over the chewing surface. Feeling creative, you could literally design your own custom articulators or dental tools. And when it's absolutely perfect, you just send it directly to a 3D printer. It becomes this complete, end-to-end digital workflow. And this brings up such a vital point, especially with all the talk about AI these days. You could have the smartest AI in the world generate a crown, but if the underlying structure it creates is a chaotic mess, it's basically useless for a professional who needs to make those final critical adjustments. The technology has to empower human artistry, not try to replace it. Things to check when using AI to automatically generate tooth crown shapes. Automatic functional and structural division of tooth shapes using AI is something we hope for, but it is not yet a reality. Currently, subdivision surfaces only allow curvature connections when connecting surfaces. It would be good if positional continuity connections were available as an option for connection methods. This is a necessary feature for connecting the margin and axial surface of the tooth. So we'll end with this thought. The goal of all this tech isn't just to replicate a tooth. It's to provide tools that are so intuitive and so powerful that they feel like an extension of the artist's own hands. It really makes you wonder, what new levels of beauty, function, and creativity are going to be possible as that boundary between the digital and the physical just continues to dissolve?